When people talk about nuclear reactor safety, they usually focus on the reactor core, the control systems, or emergency backups. But there's one overlooked component that can cause real trouble: the second cooling loop. That's where heat goes after it leaves the reactor. And in research reactors, this step can become a hidden vulnerability. The problem with evaporative cooling. Most research reactors today use wet cooling towers, evaporative systems. They're efficient, sure, but there's a problem. As water evaporates into steam, all the salts and minerals stay behind. These salts build up on the heat exchanger tubes between the first and second cooling loops. That causes a fouling and scaling, a reduced heat transfer, corrosion, and worst of all, frequent chemical or mechanical cleaning, which always comes with a risk: damaging heat exchanger tubes and potentially compromising the boundary between the radioactive and non-radioactive sides. Why this is critical in research reactors. In research reactors, this matters even more. Why? Because power levels are modest, but purity of the cooling system is critical. Even a tiny leak can mean radioactive contamination or neutron spectrum imbalance. All of that just because some salt stayed behind in the system. The alternative: dry cooling. There is a cleaner, safer, though less efficient, solution: dry coolers. In dry cooling, no evaporation, no contact with the atmosphere, just a sealed water circuit cooled by air, no salt buildup, no scaling, no chemical treatment. Yes, thermal efficiency is lower, but in research reactors, that's not a deal breaker, because reliability and cleanliness are far more important than squeezing out every kilowatt. Here's the paradox. Dry coolers aren't widely used in research reactors, even though they solve several key problems. Maybe it's time to change that. If we're serious about long-term safety and minimal maintenance, we should focus not just on what happens in the core, but on what happens to the heat after it leaves. Think beyond the core. Safety is in the system.